And our next speaker is a senior iOS engineer at the Lake company. What is important for her? A passion-driven mindset and the goal to produce desirable and meaningful products. And about the talk, pixel perfection. How does it sound for you? Especially how to achieve that in iOS UI across all devices. So Karolina is about to tell us how to make that experience more pleasant in both Swift UI and UIKit. So approaching design system in iOS environment by Karolina Samorek.
Now it should work. Okay. Hello, everyone, again. Today, I will talk about approaching design system and making this experience as delightful as it is possible on iOS. My name is Karolina Samorek, and I'm senior iOS developer at Lake. Since I started iOS development, every time I was working on the UI, I had mixed feelings. From one side, I really like to work on beautiful things and being able to interact with something I developed. However, it wasn't always like that. I struggled with creating same things over and over again with edge cases like different screen sizes or waiting long to see the result due to the compilation time. So during this talk, I will show you what works for me to limit those frustrations and embrace building UI. First thing you can do to make your experience with UI more pleasant is shorten waiting time. And yesterday, Krzysztof had a great talk about it. I will not tell more than he did during his talk. But I have one comment regarding what he said. For me, Xcode previews, if they work, are great. I can see the results on multiple devices at once. But in order to make them work, you have to have the modularized code base and build just a small portion of your code every time you change something. If it comes to edge cases, many of them are just related to trying to build the UI on a variety of screen sizes. Sometimes it's just not physically possible to fit the same content in all of them. Like, for example, on the smallest iPhone and biggest iPad. Another time, to look more friendly for the user, the content has to be constructed differently on each screen size. And each of these exceptions is basically an if in your code. So to simplify things, at Lake, we created size variants. And you can think about them as extended size classes that let you declare rules for each screen size. Instead of making exceptions, we describe the behavior for each variant. And we use that type to define things such insets, ratio of UI elements, fonts, or even different image assets. And if you take a look on size variants, it's a simple generic struct. It should define variants in a way that fits to the product you are building. As an example, Lake is iPad first. So for us, the regular is the default variant. It handles all iPads in portrait orientation, excluding split view. In our case, it is common that iPad in landscape have their dedicated layout. So we have a variant called wide. Compact is basically iPhone in portrait, as we don't support landscape orientation for iPhones. And to handle this edge cases for smaller iPhones, we introduced two more types. The short one, which takes care of iPhones with screens smaller than 4.7 inches, and small for the smallest iPhones with 4 inches screen size. You can see that the variant, if not defined, fallbacks to the larger one, and at the end to regular, which has to be always provided in our case, because this is like the base for us. I didn't thought about doing this before. Sorry. So next topic on my list of UI frustration is repetitive work. And the best way I know to eliminate it is to adopt the design system. Simply create a framework that will let you build your UI with reusable components. And there are many ways you can approach it. However, there is one significant thing I've learned over the years. The design system is a product itself, just like apps we work on. And this product, as all of products should be designed having best interests of its users in mind. And by users, I mean, of course, designers and UX researchers, but also product owners and us, developers. And to get the maximum out of the design system, each of those groups has to be involved in the process of creating it. You can start from defining tokens, which are parameters we will later use to style components. Tokens can be things like fonts, colors, icon or spaces, etc. And if you already support UIKit and SwiftUI, or you are thinking about transitioning into SwiftUI, remember to define your tokens in a way you will be able to use them in both platforms, in both frameworks. You might use UIKit types and convert them to SwiftUI ones, or the opposite. You can also create your own types. Like here, for example, we have a type design system color, which uses CG color from Core Graphics library. And because of that, it's independent from UIKit, but can be easily used with it, as well with SwiftUI. Then you can start thinking about all possible states you want your controls to have. For example, the normal state when no user interaction is being performed, or highlighted when user taps the control. And of course, disabled when no user interaction is possible. And now, by combining tokens, control states, and size variants together, you can define styles of your components. Let's follow an example of styling call to action button like this one. It has some font, corner radius, and a background color that changes with a tap. First, we defined font for a button. It is a size variant of design system font, and it will be always the same for each screen size because we provide only a regular variant here. Later, we use it by calling a helper method and converting it into a view attributes with a specific text color. And then we convert text style we just defined to a button attributes by applying attributes for normal and highlighted states, such as background color and corner radius. And then we define content inset for iPhone and different content inset for iPhone and iPads. Like, for better understanding, let's take a look on example attributes that define style of a view component. Things like background color, corner radius, some border or shadow. How you define them depends on how your design system looks like. So, like, please treat them as an example here only. And to apply those attributes to components, create set of methods and types that will help you. Like for button in SwiftUI, where you can implement a struct conforming to button style. You can see that attributes for current control state are applied by delegating text and view attributes in separate methods. And also padding is being added. And changes of control state are animated. In UIKit, we can use same attributes. However, we have to write separate functions applying those styles, as our controls have different API. And there are like more methods like those I've shown. Good thing is the attributes are composable. So for example, view attributes contains shadow attributes and border attributes. So you can compose also function that applies those attributes and write them once to use them later on. Here you can see like the shadow attributes are applied in separate functions because they are these are like subcomponents of our view attributes. However, it's not what I want to dig into today. If you are interested, there is a repository on my GitHub where you can find more details about like view attributes and functions that compose them. But like not all is pushed, but yet, but you can expect this soon. But let's focus on the main topic and go to some like example code. And before I have shown you how to style a call to action button. And the style we defined was on the design system level. However, we can also take advantage of the styles on the feature level. Imagine we have to create a banner for WWDC community event. And it should like this. Nothing super fancy, but it is slightly different on each device. It might not be visible on first look, but the ratio of the banner is different on iPhone and the iPads, and also the title on iPhone SE is smaller. So a few edge cases we have to handle. We can start from defining feature styles by reusing the design system. Like taking already defined shadow and converting into view attributes with some corner radius. And we can take similar approach to declare other styles. We basically take what design system provides and build on top of that. Having styles defined, we can start building UI. Here we have just a background of the banner, and we already provide assets as a size variant. And now you can could ask me, why don't take advantage of Xcode's assets and instead of universal, define the iPad and iPhone separately? However, split view would then look really bad because it would use the iPad one, but the view would be narrower. So by simply adding one function call, we restyle the background to have rounded corners and shadow below. Let's now take a look what we can do with the foreground. Simple VStack texts, button and spacer in between should work here to place them in correct places. So let's add them to our banner as an overlay. Well, we are going in the right direction, but it doesn't look like on the designs yet. We have to style the components we just created. Again, few lines of code and UI is transformed. And the best thing is that it does all the magic for edge cases. So let me show you how it behaves. You can see it looks good in portrait, landscape, and even in split view. And you can see from the banner ratio that it uses different screen size variant for split view than for full view. So building our example with Swift UI was pretty straightforward. But what with UIKit? Some of us still have to write code, like write UI with it. And for those, design system has to support both framework. Let's see if we can adopt our design system by building some example with UIKit. But before we go, let's add some types that will help us with this. Again, this is just an example of how you can approach it. I wanted to make it as clear as possible and declare attributes close to the components. So I thought, if I still have to use UIKit, why not take advantage of another modern feature of Swift and use property wrappers? So here it is. It stores view together with its attributes. And also, it's able to observe layout and perform updates on screen change. Of course, if you want your views to be able to update with this property wrapper, you have to make them conform to attributed view. And then, having view controller for WWDC banner, all we need to do is add property wrappers and start observing the layout. Well, this is almost all you have to do. It's UIKit. It cannot be like too easy. So I'm not sure if you remember, but our banner has different ratio for iPhone and iPads. So we have to take care of one more thing, the constraints. I don't want to manually update them every time, like for every view or view controller, every time screen change. So here is just like wrapper class on a constraint that observe changes on the of screen and update the constraint. There is also a little helper method that activates and trigger observing layout for array of constraints. So then we can simply use it, but by just declaring the constraint and activating it. And here you can compare the results for Swift UI and UIKit. And as you can see, they are like, when here is the switching the tab, it's different view, but they are like identical. I guess that's proof that it is possible to have a design system that works pretty like easy with both SwiftUI and UIKit. So thank you all for being here today. If you have any questions, now's the time.
Okay, I see first question.
Oh, I forgot. I have some gifts.
Hi, thank you for presentation. I noticed some small property. You define the fonts with a exact value. What's your take on dynamic fonts and how you use it in your framework? Is it possible to use it? And just generally, do you prefer dynamic types or just exact values? Because I mean, in typography is really important in UI because it makes like the 90% of UI and the feel of the UI, and that's why I'm asking.
Can you
I mean, you for button text you have some value like 17 or something like that.
Yeah.
And why not using some regular or headline or something like that?
Okay, so this was just
No, I know it's example, but I mean your perception of the dynamic types versus exact values.
Well, it's more like, in our case, designers really like to look on the effect of how it looks on different screens. So I gave them the final decision. And if they see, I was trying to find the, oh, so you are referring to this line. Yeah, if they are saying it has to be the same for each device, then I'm not in the place to change it. They do that in our case. So they define the specific font size. If that's answer your question.
Maybe I missed the slide with this information, but how do you recognize what kind of size of device is using right now?
Okay, it wasn't on the slide. It is on my GitHub. We basically have one layout class. Maybe I will not find it now, but we have a layout class that contains the screen object, and this is observable object. So we have one root controller that reacts to the changes of the screen and update this object, and then it is just propagated to other views.
I saw you using property wrappers in your presentation. So have you thought about also using maybe function builders, view builders, and extending this code base for SwiftUI and creating some kind of DSL for even easier creation of SwiftUI views?
Well, we have such view builder functions that apply those attributes, but it's it depends on which level you want to use it. So design system defines those rules, and also we have the framework, the library of some utils to design system, and then we use those utils, this view builder functions, to apply those attributes. Just like you said, sometimes it's redundant work, so it's nice to have this view builder function that will apply your styles, or even don't have to apply them because it will know that you want to create this call to action button, that it looks always the same in your app. So there is just one like function. You don't have to even pass any properties.
Okay, thanks.
Hi, thanks for the presentation. So my question is, at some point you showed the screen where you added an image view and then you added a button and then you added a label, etc. And what I found with this approach when working with UIKit is that sometimes you add just a little footer below the button and then the whole layout breaks. So my question is, from my experience, I usually put everything as a collection view. Every screen is a collection view. What's your opinion about this? Do you think that this is a valid approach sometimes? Which are the cases? And why not wrap everything in scroll view or collection view for the simplicity's sake?
Okay. I think like our app is basically one big collection view. Like each of the main screens is a collection view. And to be honest, I like it and I hate it. Sometimes it's easy to append one change, but also like it is building more complex view. For this case, like few views, it wouldn't make sense for me to like create collection view here, especially that I don't want this like content to scroll. And collection views are not so easy to deal with. I mean, especially if you want them to have like the custom layout and so on. So I don't know, to be honest. It just like depends on the case. Do we have more questions? Okay.
Hi, thank you for your talk. I've got a small question about accessibility. You've created a whole wrapper around Swift UI views or UI views. And I've also noticed that you've created 3 states. I'm not sure if this is full code, but
No,
probably
it's not.
button has a 6th state. I don't remember correctly, probably. But how about supporting accessibility labels? And how about supporting features like cursor on iPad? Right, because you are mainly iPad focused.
Yeah. So, like maybe I first start from the accessibility. It's not the thing to brag about, but we don't do it properly. So I will not answer your question. I think we will come eventually to that point to include accessibility in our app. But we are like the team of like the whole company is 10 people. So it's not so easy to introduce the set changes. But if it comes to like the cursor on iPad, it's also not really our case because we do like the core of our app is coloring the drawing. So you don't do it with the mouse. You can do it with Apple Pencil, for example, but like this is completely different engine and it's not done with UIKit or Swift UI. So like this main component. So I don't know if I have answered your question here.
Okay, anyone else?
Okay, so for the people who did answer the question, I have some swag. You can come here later and take what you want. Okay, so thank you again.
Thank you.